Hello and welcome to my tutorial on reaction mechanisms. So we're going to go through a couple of reaction mechanisms. One of them is called radical substitution. Now, a reaction mechanism has an initiation step in which non-average molecules are turned into special free radical molecules. Now, a radical is an atom or molecule with an unpaired electron. The unpaired electron is the key part in this definition, and these radicals go on to form different compounds with the unpaired electron, and the radical eventually gets cancelled out in the third and final termination step. So first step is initiation, in which a bromine molecule becomes a bromine radical under the presence of UV light. And propagation is when the radical reacts with, in this case it's methane, to become a CH3 radical plus a hydrogen bromide molecule, and then that CH3 radical reacts with a bromine molecule to become CH3 bromine plus a bromine radical. So bromine radicals are used in the first propagation step. It's then regenerated in the second step. Radicals are always regenerated until termination step, when the radicals cancel. They catalyse the propagation stage. Bromine radicals are not consumed throughout the entire reaction mechanism up to now, the termination step. So when a radical reacts with another radical, it becomes a normal molecule. So that becomes CH3 bromine, and this bromine radical so when two radical radicals of the same species react together, they become a bromine molecule, and when these two react together, they become C2H6, a double bonded molecule. Note. So when a radical combines with another unpaired electron with the carbon, it becomes an alkene. So if we look at another type of reaction mechanism, so that was radical substitution. We are now moving on to, when the board loads, come on Windows, you can do it, electrophilic addition. So this is when an electron pair moves to make an ion, and that particular ion forms to make a stable molecule at the end here. So we'll go through each step. So at the first step, a halogen, like chlorine, the electron, a pair of electrons from the carbon-carbon double bond move to the chlorine atom at the delta positive end, and then we go with electron pair to the chlorine atom here, and this forms a chlorine ion, which is what is known as a carbocation here, as an electron has been removed from the carbon. So when that carbocation exists, a chloride ion can go this region of low electron density and attack the carbocation. I know it sounds a bit odd, and this will then become 1,2-dichloroethene. Ethane, because it's an alkane. So once the two have reacted, I'm sorry, that is not a H, that is a Cl there, as one of the chlorine atoms are bonded due to the first step. They're bonded to that carbon atom, and the carbocation forms, and then that resulting, the electron pair moving from there to there forms that ion. So if I draw a dot cross diagram correctly, that cross would come from the bond, from these bonded electrons just moving from the bond. So here's the bond, and that electron pair would move to the chlorine to form a chloride ion, and then the chloride ion would attack the carbon to bond and produce 1,2-dichloroethane. And we look at the third and final reaction mechanism now, nucleophilic substitution, in which a nucleophile becomes an electron pair donor. So this is a nucleophile, an OH- ion. Now, a nucleophile can take on many forms, but basically any species that can have a lone pair in its electron arrangement is generally considered to be a nucleophile, like ammonia or oxygen. When it's bonded in H2O, well, oxygen just on its own can be a nucleophile, but OH- and NH3 are the two most common ones. Anyway, the lone pair from the nucleophile attacks the back of the carbon atom, donating an electron pair, and this is again the region of the least electron density. Now, if we think back to molecular shapes, that all of these electron pairs are repelling, so you will have a region of space where the electrons are not residing as much. So the bonding pair of electrons will move to the carbon atom, and a new bond will form, and the carbon to halogen bond here breaks because the bonding electrons move to the chlorine to make a chloride ion, and that's the end of the reaction. We get, if I draw this normally, we get methanol and a Cl- ion. So that's all the reaction mechanisms. So if I do another example, just to get this understood one more time. So we'll have ethane now and chlorine in an ultraviolet radiation reaction. Now it would be a radical substitution. So if I do a jump cut, I will draw the reaction mechanism now. Right, using the power of jump cutting, I have drawn out the entire equation. So we would get C2H9. Oh, no. Yep, I will just write the normal formula: C2H9 plus Cl. Nope, HCl. That is the overall reaction. So initiation stage 1 is the chlorine radicals becoming the chlorine molecule becoming a chlorine radical, and then at propagation we have the chlorine radicals reacting with C2H6 to become a C2H5 radical plus HCl, and then C2H5 dot reacts with another chlorine molecule and C2H5Cl plus Cl dot. There. Termination, we have C2H5 plus Cl dot to make C2H5Cl. Cl dot plus Cl dot neutralizes all the radicals, and C2H5 dot plus C2H5 dot gives us good old butane, C4H10. So that's it for this tutorial. The steps you have to remember for radical substitution: is initiation, propagation, and termination. So, and reminder to the other two very important reaction mechanisms. Nucleophilic substitution is when a lone pair of electrons are donated to an electron deficient carbon atom, and electrophilic addition is when an electron pair moves to a carbocation to form usually a dihalogen molecule. And that's it. Thank you for watching. Hope this was helpful. Leave a comment in the comment section below if you want to, and goodbye.